Alright, so this video and these string of videos are going to focus on section 6.2, and we're going to learn another method to solving a system of equations, and this one is through substitution. Alright, so in the first video we've already learned how to solve through graphing, and now in this one we're going to solve using substitution. Alright, so our objective or our goal for these two videos is going to solve systems of equations using substitution. Alright, we're going to be using that method throughout. In the first video we're going to do just regular ordinary systems, and in the second video we will do the special cases that we did before with the graphing. So it'll be special cases. Alright, that will be video 2. Alright, so what is substitution method? So you can model fair trades with a linear system, and you can solve linear systems by solving one of the equations for one of the variables, meaning that you can say x is equal to or y is equal to. So you solve for one of your variables, and since we know what that x or that y are equal to, we can then substitute the expression for the variable in the other equation. That's the key thing there, other equation. Right? So you want to make sure you're substituting it into the other equation. And this is called the substitution method because we're substituting the expression in for the variable in the other equation. Right? And what I want you to understand throughout the first 3 sections of this chapter is that systems can be solved in more than one way. There's not just one way of solving systems of equations. We've gone through graphing so far. Now we're going to go do substitution, and then there's one more method called elimination later, and you need to be able to identify which one's the best for you. And the way that you know that you want to use substitution is when one equation can be solved quickly for a variable, so that we can quickly or easily say x is equal to or y is equal to. And that's when we know that substitution would be the most efficient way of solving, the quickest way of solving. But like I was just saying, there's 3 different methods you can choose. You can choose any one that you want at most of the times. There will be times on the tests where it says solve using substitution or graphing or elimination. But other than that, you can use whatever method you feel most comfortable with. Alright, so now let's go ahead and let's start doing a problem using substitution. Alright, so the first problem we're going to do is what is the solution of the system, and they said specifically to use substitution. Alright, so when we use substitution, we want to either see is one of our variables already set equal to something, or can we quickly and easily solve for a variable? Well, in this case we have y is equal to 3x. So that means wherever I see y, I can substitute 3x in for it in the other equation because I know that they're equal to each other. So instead of x plus y is equal to negative 32, I can then substitute x plus y, but instead of y, I can substitute 3x, and that is equal to negative 32. Alright, so now the reason why we're doing this is in this equation, we only have one variable to solve for now. We only have one variable, and that's x. We can solve for an equation that has one variable. In this equation or this equation, we have an x and a y that we need to solve for. And we can't solve for both at the same time. You can't solve for an equation that has 2 unknowns. You have to narrow it down to get one unknown. And by substituting, we now rewrite this first equation of x plus y, 2 unknowns, to x plus 3x, which will only have one unknown x. And now we can solve x plus 3x, we know is 4x. We divide each side by 4. X is then equal to negative 8. And now once we solve for one of them, it doesn't matter which one you plug it into. You can plug it into either equation you pick, and then you solve for your y. Since this one is already set equal to y, I'm just going to substitute it in there. So y is equal to 3 times x, or since x is negative 8, y is equal to 3 times negative 8, and y is then equal to negative 24. So the solution that satisfies both at the same time is when x is negative 8 and y is negative 24. And we can plug them into our 2 equations to make sure that they work. So let me just erase this really fast. So in this one, y is equal to 3 times x. So we're checking, does negative 24 equal to 3 times negative 8? Negative 24 does equal to negative 24. So yes, it works. And then the second one that we'll substitute into, does negative 8 plus negative 24 equal to negative 32? And negative 8 plus negative 24 is negative 32, and it equals to negative, so it works for both. All right, so that just shows, if you want to check your work, you can see that it works for both at the same time. All right, there's one more question that we're going to go through, and then that's it for this video. So this problem says, what is the solution in the system? And it tells us to use substitution. So just like the last question, it does say use substitution. All right, so it's telling us what we have to do. But unlike the last question, this system here is not set equal to one of our variables like this one was. And this one was clearly said y is equal to 3x, so we knew exactly what we were going to do, substitution right away. However, in this one, we do have just plus y, and we can quickly and easily solve for that y. If I just add 2x over, I get y is equal to 2x minus 3. Right, so I was quickly and easily able to solve for that y. So sometimes we will have where y is just equal to, or x is just equal to something, and it's quick and easy. But if you don't have it written like that, what you're looking for next then is, do one of your variables have a 1 in front of it? Do you have a 1x or a 1y, or just an x and just a y? And if you do, you can quickly and easily solve for that variable by just adding or subtracting over everything else. So we were quickly and easily able to solve for y. So now we have the system of y is equal to 2x minus 3, and 3y plus 4x is equal to 14. And now, once again, we know what y is equal to. Y is equal to 2x minus 3. So wherever I see y in the other equation, I can rewrite 2x minus 3. So 3 times 2x minus 3 plus 4x is equal to 14. So same thing. Here, I'm down to one variable now. I only have x I need to solve for. Here, I had 2 x and y and 2 x and y. So this narrows it down, or allows for me to go ahead and start solving. I distribute the 3 in. So 6x minus 9 plus 4x is equal to 14. Well, then we can add over 9 to both sides. And then we will combine our like terms. So 6x plus 4x is equal to 10x. 14 plus 9 is equal to 23. And then we divide each side by 10. X is then equal to 23 over 10, or 2.3. Right, now that we know what x is equal to, we can then set it into any one of these equations, back into any one of the three that we have, because these two are the same, but they're just written in different ways. But since this one is already set equal to y, we'll just substitute x in for that. So y is equal to 2x minus 3, or we know that x is now equal to 2.3, so y is equal to 2 times 2.3 minus 3. So y is then equal to 4.6 minus 3. And 4.6 minus 3 is 1.6. So our answer for this is x is equal to 2.3 and y is equal to 1.6. And then to check your work, you can substitute it and plug it back in and make sure that it works for both. All right, that is it for this video.